Thank you very much, Kim and Jin. That was really an amazing presentation. It's incredible how with GIS you really can go farther than network adequacy. You can start thinking about optimizing your network, assessing the risk on every provider in your network in order to improve it. So the problem of access to care and optimization really can be improved using GIS. But now it's my work to show you how you can take the most advantage of the analytical power of GIS. But before doing that, let me talk a little bit of the context so we are in the same page during this day. I'm sure that during this day you are understanding that GIS is more than just software. GIS actually is a system of systems. It's a system of records because you can integrate different kind of data sources coming from different systems, from social network integrations, and even from other organizations that provide health data. And you can use a common framework to do this integration. What is the name of that common framework? Location. But also, GIS is a system of engagement because you can share your information using obviously access standards that probably you already have in your organizations, but you can share not only data and maps, but even geoanalytical power, geoanalytical tools, or analytical workflows that you create using GIS through your organization. So people can access to them anytime, anywhere, and using any device. But finally, GIS is also a system of insights. And what I mean when I say system of insights is basically a system that will allow you to understand, measure, and even make predictions on top of your data. So let me go deeper today on GIS as a system of insights. Today, I will show you two different ways on how you can take advantage of GIS as a system of insight. I will start showing you how you can take advantage of insights for ArcGIS, which is an amazing new tool that will allow you to leverage the power of iterative geospatial analysis in a completely new yet easy to use interface. And the second tool that I will show you today, the second component is ArcGIS Pro. ArcGIS Pro is a new desktop application that will allow you to use most of our most powerful machine learning capabilities. And the reason that I am separating these two elements is because most of you have different background, right? There are people that not necessarily have to do work directly with GIS. Some of you maybe don't have experience using GIS. So Insights will be a really amazing tool for you to start with. It does not require to have a previous GIS experience to use. But some of you probably have that experience and you want to go further. So I will show you how to take advantage of ArcGIS Pro. Now, there is a quote that I really like that you can see it right now in the screen and is related to something really important. We all know that data is important. However, what we should carefully understand is that what is most important is answers. Because with answers, I can take decisions. So data is important, but answers is what I am looking for. And the stories that data tell me are the context that I am looking for. And Insight for ArcGIS is one of my favorite tools because it helps us to find those answers among our data. Now, Insight for ArcGIS could be understood in two different ways. It's a tool that will help me to do data visualization. There are many different ways to visualize your data using Insights for ArcGIS, but also Insights is a tool where you can do GIS analysis. So what you have here is basically the intersection of GIS analytics and data visualization capabilities in just one tool. But now, in the new version of Insights, now you also are able even to do data science analytics. And we are extending to the infinite, I would say, the capabilities of Insights for ArcGIS, allowing you to integrate Python and R code into Insights. So instead of just talking about Insights and how it works, let me show you a quick demo that I think will illustrate clearly what I am talking about. All right. So for this demo, let's talk about South California Health System. It's just an example. But this is one of the leading health systems in the region. And in the last 2 years, they have noticed that the rates of asthma hospitalizations are increasing drastically. So they are planning to create some key interventions in the area in order to reduce the rates of readmissions for this cause. So they have access to the RJS platform, they have access to insights, and they want to use the power of insights to understand their data. So here right now I am in a web browser and I have access to the database from South California Health System. And let me pull this table into the canvas and you will see that there are three options in which I can visualize this information. The first one is map, charts, any charts, and table. Let's start with a map. Here what you are seeing is the service area, the census tract information within the service area of South California Health System. Now, if I go ahead here to symbology and I select asthma hospitalization, let me go ahead here, asthma hospitalization, you can see how easy it is to create a map that shows me the concentration of asthma hospitalization in a geographic way. It is easy now where there are pockets of high concentration of asthma hospitalization in this area. Now, what about if I want to see really, in a better way, this information in a different way? Maybe I want to see a chart that shows me this concentration of asthma hospitalization per city. So that's really easy to do. If I go ahead here and select the field name city, and then asthma hospitalization is 2, I can go ahead here, select chart, and select tree map. Here, let me go ahead here. I don't know what happened. I just, interesting. Let me try again. City, asthma hospitalization. There we go. Chart, tree map. There we go. That was very interesting what happened before. But there we go. So we have the distribution of asthma hospitalization per city. You can see how this chart communicates the message really quick. The biggest chart or the biggest square is this one, back noise. And if I click here, you can see how the map is filtered. So there is an important concept here. And be ready because this is really impactful. Every component that I am using here is interconnected. So for example, if I go ahead here and select analysis view, you can see that every step that I am taking is being recorded as a part of a workflow that can be shared to anyone in this organization, and they can refine with me this analytical workflow. And this is a functionality that you won't find anywhere else. It's a functionality that make this tool not only a GeoBI tool, but an iterative analytical workflow for your organization. So let's go back here. And now, what about if I want to pull information related, for example, smoking or children, but I don't have access to that kind of information in my database? How I can create or how I can get that information from ArcGIS? Well, there is a process called enrich data. And with enrich data, I can go ahead here and look for all the information related. Let's say I want to information related to children. because they are very vulnerable in terms of asthma. Let me go ahead here. Children less than 14 years old. And then smoking. I select smoking. Go ahead here. Smoking. Okay. The rates of people smoking cigarettes in the last 12 months. I just need to apply this, run this process, and as a result, what I will get, give me a second here. As a result, what I will get is a layer like this, the enriched layer. And if I go ahead here, you will see that I have the smoking data as well as the children data that I pulled. Where is it? Children. I'll give me a second here. I think it's in the second two. There we go. So children, let's go ahead with children. Children per city. And look what I will do. Children per city, ping, bubble. And now I can see what are the rates of children per city. And look at this. Bangnois have a high rate of hospitalizations, but also have a very high rates of children. And that's very interesting. Maybe I may like to explore a little bit more this. And in the same way, I can create another visualization for smoking products. In this case, is a KPI. So again, if I filter by noise, I can see the rates of children, but also I can see how much people are spending in smoking products. So this is really cool. You can do this kind of analysis and refine it with your team. Moreover, there are different ways to do analysis here. I am sure that most of you create indexes, right? You normally take many variables that you know by expert opinion that are correlated to asthma, for example, and you want to create an index that illustrate, say, the vulnerability of specific zones or places to asthma. And to do that, what you will do is take, for example, particulate matter, then you will take traffic concentration, then maybe the rates of cardiovascular diseases in the sun. Maybe that's an important variable for you. So you want to take those variables and then you want to merge them into an index. However, normally these variables don't have the same scale, right? The rates of cardiovascular diseases could be one person with cardiovascular disease or one person hospitalized by a cardiovascular disease to 1,000 persons in another census tract. Whereas when you talk about particulate matter, the measurement for that is very, very different. So how you can normalize that information and create an index? Well, if you go to analysis and you go to how is distributed, there is a tool called Calculate C-score. And basically what this tool will do for you is normalize these columns, this data, using C-scores, which is basically the how far or how many standard deviations a value have in relationship to the whole data set. So let me show you how this will look like. If, for example, we have calculated the C-score for PM, particulate matter, you can see here the zones, the areas that are more purple are zones that have at least more than 1.5 standard deviations than the normal average of the data. And the brown zones have 1.5 or minus 2.5 standard deviations than the average zone. So that means that there are low rates of PM, particulate matter, in those brown areas, and high rates of particulate matter in these purple areas. The same with use prescriptions, drugs for asthma, what else? Smoking products, and so on. So we have a standardized value now. And taking these four values, what I do is to create a vulnerability index. So you can see that there are many applications for this. Really, you definitely will take advantage of this kind of thing. Now, what I'm about to show you is something really cool. It's data science. How you can apply data science using Insights for AIS. And I will take advantage of that topic to show you another thing. And is that Insights is also a desktop application. So here, for example, what you're seeing is again the service area. And what I can do with this is compare different values. For example, asthma hospitalization. I want to explore what are other variables that could be correlated to asthma hospitalization. I want to explore my data to see if there is maybe some correlation. So I will select asthma hospitalization. Then let's go ahead here, particular matter, toxin releases, cardiovascular diseases, poverty, education, children, education and cardiovascular. There we go, these two. And then what I will do is go ahead to chart and select the scatter plot matrix. And basically what this matrix is showing me is here, R squared, how correlated are my variables to asthma. So here we have the asthma variable, and we see, for example, that asthma and cardiovascular disease have an R squared of 3.1. So there is kind of a correlation, and you can see here that there is kind of a correlation between these two. It's not a strong one, very well defined, but it's maybe a variable that I want to explore. The same with asthma in children. There is an R squared of 2.6, and so on. So even if I want to explore, let's say I want to explore this specific correlation, I can pull this one here and see this in more detail, right? And even more, say that, for example, you have here this one. Say that, for example, you are evaluating right now a linear relationship, right? But you see visually that maybe it's not a linear relationship, maybe it's a polynomial relationship of a third grade, and you see that the R squared evolve, or maybe it's an exponential correlation. And understanding that is key because if, say, for example, it's an exponential correlation, you can apply a log function into your data and make it a linear correlation, and you can work with that. So uh, what I'm trying to show you here really is that you can go very deep in analytics and insights for GIS without being a GIS analyst. Finally, even here in Insights, you are able to use Python. So here, for example, I am able to enter here and start, doing Python script, print Python. Mm, 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 mm. There we go. And you can see how I can do basic commands. I can go very complex here. Say, for example, that I want to print or I want to create a chart. I just need to go ahead here. Maybe I have an inset of data here. I will enter here my table. Then I want to enter my one of the variables that I want to compare in this Python chart. And I want to enter another of the variables that I want to compare in this Python chart, cardiovascular disease. Enter. And as a result, I got a chart that is comparing asthma with cardiovascular disease in a complete different way. I just need to select this, enter this, and look at this marvelous thing. You can create any chart with Python, really. And in the same way, what I did is I basically create different charts using, in this case, R. So I have a chart created by R and another with Python. So this is a really quick demo on how much you can do really with ArcGIS. But now let's go ahead and talk about another tool that is called ArcGIS Pro. And here I want to ask a question. How many of you have ever used ArcGIS Pro? Could you raise your hand? Very cool. So many people here have been using Pro. And I won't go deep here, but Pro is the new version of desktop tools that we have. It's a very powerful tool. is built in a 64 bits multi-threaded environment, so you can take advantage of the full power of your computer. But in Pro, you really can leverage analysis. And basically in Pro, you can pull Esri data, and then you can pull information from your internal systems, electronic health record system, and so on. And then you can apply GeoAI tools. And let me talk to you a little bit about some of those GeoAI tools. There are tools for clustering, for example. And most of you probably know this quote. Um, any of you remember who said this? Anyone can raise their hand? Yes, Tobler, right? This is the first law of geography. Everything is related, but closest things are more related than others. And in Esri, using a concept called spatial autocorrelation, we measure if there is an statistical significant concentration. We use statistics here. We use z-scores and p-values to define not only if there is a concentration of values, but if that concentration is really caused by other variables. So for example, here we have a map that is showing the cost per capita of Medicare across the United States. And visually, we kind of see a pattern, right? But if we apply a hotspot analysis, now the pattern is really clear. And if I select the north, you can see my mouse here. Here in the north, maybe I can use the laser better. Here in the north part, it is really clear that there is a concentration that in the other form, it will be a really harder to see. And the important question here, the most valuable outcome of this map is that what this map is telling me is here there is a concentration, and you may like to explore why there is a concentration, because you know that this is not a random concentration. Now, we have a new tool also for evaluate concentration of clustering, and it's a tool based on a machine learning method called density-based clustering tool. And this tool basically is it's amazing. It's a machine learning non-classified, sorry, non-supervised method. And let me show you how you can use that. Oh, but before, you know what? Before I show you this, let me enter into uh, another concept so I can, make a demo that shows both of the concepts. And I want to talk a little bit about regression and classification. Okay? Most of you know that why the reason that we use regression analysis is because we want to explore correlations, we want to predict values, and we want to understand key factors. In the case of health, we want to understand what are those main social determinants of health outcomes so we can better treat, we can better take care of the community we are serving. Now, there are different methods in our platform to do regression analysis. We have a very powerful tool called geographically weighted regression tool. And this is really important for you because here with this tool, we really are taking advantage of geography. So for example, OLS or any other regression model that you have been used will generate a general model for the whole geography area that you are analyzing. But with geographic weighted regression, the tool is creating a model for each of the units in your geographic unit, in your geographic analysis. So for example, if we are talking about census tracts as hospitalizations, it will create a different model for each census tract based on the whole data set. Why this is valuable? Well, because, for example, here, talking again about Medicare spending, say that you want to predict Medicare spending in the south of United States, right, for next year. With this tool, you can create a model that do this prediction, but more importantly, this tool will give you uh, what we call different rates. So in other words, what you are seeing here is not only the prediction of this tool, but also what you're seeing is the coefficients of each of the variables that were part of the model. So for example, if we are predicting if we are predicting Medicare expenditure in this area, and we use diabetes rates, readmission rates, and imaging services as the predictors, this tool is telling you where in the area, let me use the laser here, give me a second. There we go. Where in this geographic area diabetes rates had a higher influence in your model. So that means that if you, for example, make an intervention related to diabetes in this area, you will definitely impact the outcome of Medicare expenditure in the model, or in reality. That's what I meant. Now, if you are very interested in this area because this is the area that have the higher rates of diabetes, sorry, of Medicare expenditure, maybe you want to tackle imaging services because if you see here, imaging services have a higher importance in this area in relationship with your prediction of Medicare expenditure. So think about it. You don't only have a prediction of the data, but you can understand how these variables, these predictors are correlated and how they behave geographically speaking. And this is really cool. Uh, Finally, we have a tool called, for example, forest-based classification and regression. You probably have heard about this famous machine learning model called random forest. And this tool is based on random forest tool and the random forest model and will allow you to predict values and create models. All right, so that was the statistical class of today. That was, I think, a lot. And you know what? Nobody wants. Okay, so let me show you very quick the demo. Let me open this here. So I will start showing you a demo that talks about clustering. Okay, and what you are seeing here is what you're seeing here basically. It's a map that is showing you patients with high rates of readmission. And what we want to do is basically we want to understand this data and we want to basically identify where there are clusters of these patients so we can maybe take in an initiative, we can create an initiative of a mobile hospital that can reach those patients and we can basically be more preventive and in that way reduce those readmission rates. So to do that, I want to identify those concentrations and I will go ahead here. So let me go ahead to open the tool. It's called density-based clustering. And here, what we are doing is we are selecting our patient information. And then we are telling, okay, for me, a cluster is more than 100 patients. So it will be worth it for me, to go with my mobile hospital and reach at least minimum 100 patients. And also, I want to do a search for these clusterings in a 1 mile radius because I consider that people will be willing to drive or walk no more than 1 mile. So if I run this tool, as a result, what I will get is this. And you see how quick it is, right? It's a very quick tool. And let me basically show you this. Give me a second. There we go. There we go. So we have all these clusters. You can identify it clearly. Where are those clusters? But now, what is really cool is we know where those high rates of, concentration of high rates of what is readmission, people are located. But now, how we can prioritize which area could be, the first one that we will visit. So again, what we can do is go ahead here and we can you enrich this layer using the you enrichment tool. So let me go ahead here, enrich layer, and we will use the variable, the percentage of or how much people are spending in fresh fruit and vegetables in the last 6 months. So that would be a good indicator because if we have a high concentration of people that don't use and don't buy, no, this is not a variable. So, and now what we can do is basically you enrich this layer, the same process that we did in Insights for ArcGIS. So you just need to use the enrich tool. And as a result, we can generate this kind of charts. For example, here we pull the variable, the number of prescriptive drugs for diabetes, not related to insulin, per each of these clusters. And we find that, for example, here, this area is the area that have more people that are not spending money for healthy products or for products that are related to diabetes in the area. So maybe you may like to prioritize this zone. So this is just an example of how you can use a machine learning algorithm and a lot of data. Another example is related to the common method or the method very well known random forest. And what you're seeing here is a map of Connecticut that is showing us asthma hospitalization. And in this map, for example, we have data for some of the census tracts. And what we want to do is use forest-based classification and regression tool to predict new values in those gaps. So if I go ahead and open the forest-based classification and regression tool, I can start training a model. And what I am using is some variables that I consider are correlated to asthma, like for example, socioeconomic variables like median income, education, also poverty, smoking cigarettes. But also I am using environmental variables, like for example, distance to air toxic releases, road density, air quality, and so on. Using these variables, the software is creating this model, as you saw here, and this model is very powerful because if you see here, it gives me a very good R square, but more importantly, it gives me a list of importance. So I can have an idea on how important each of these variables is in relationship to my model. And actually, if I go ahead here and open the tool, the chart, you can see that I even have a chart that is showing me that median income is really important to predict asthma hospitalization, as well as health insurance, smoking cigarettes, and so on. So as a result, once I train my model and I am sure that it's a good model, I go ahead here and instead of train the model, I can predict the features, run the tool, and get something like this. Give me a head. There we go. A complete prediction of the whole area. So that's a very interesting example. Now, to finish this presentation, I just want to talk very briefly of something important. How we can deal with massive amounts of data. How you guys can deal with millions of records that you have related to your clinical information. Well, we have a set of tools called geoanalytics. And I just want to go ahead here to show you. Here in the tool set, if you have ArcGIS Pro, you will have access to geoanalytics desktop tools. And basically what geoanalytics will do for you is to parallelize the processes. So to put it simple, it will create chunks of data and it will create independent processes to minimize the time that it takes, for example, to geocode your data, to aggregate your data, to create a hotspot analysis, or whatever machine learning method you want to use. So let me go ahead here. For example, I have a lot of patient data here, not only the height readmission rates patient, but all my patient information. And if I go ahead here and select aggregate data, I can select all this massive data set, select, for example, here bean. I want hexagon beans. I want these beans to be just 1 mile of size, and that's it. I can run this, and I just want to, I just want you to see how quick it is, this process. It is taking the data set and it is uh, splitting this process in 4 parallel processes here, as you can see, and that's it. We have an aggregation of all my data. So in the same way, you can process national data. So let me go ahead here. There we go. So what you're seeing here, for example, is national data of patients aggregated. Or maybe you can take the massive database that comes from the National Provider Index. And what I did is I took the 5 million records of that database and I aggregated them by county. So you are seeing the rates of cardiologists per county across the United States. So I am sure that you have a lot of data, and these tools really can not only allow you to do powerful analysis, but you will be able to do fast and quick and accurate analysis with geoanalytics. So thank you very much for your time. I hope this was very instructive for you. See you soon.